Hello, this is Łukasz Gandecki, and today I want to show you how you can add Chimp to an existing Apollo-based application. The first step you have to do is called Chimp with a command init. We use npx here, which will look for Chimp installed globally, and then it will look for Chimp installed in your node modules. And if it doesn't find it, then it will just temporarily install it. And that's what happened here. We are just adding Chimp to our application, so it's not there yet. It's not in the node modules. It did a few things for us. It created some example code, added project dependencies, configured tsconfig JSON, and added empty GraphQL context file. I will be taking a look at those changes in a second. One thing that it didn't do is it didn't configure jest because there was already an existing jest config.js file. And we don't automate configuring it yet, but we have a link here that explains what you have to do manually. We need to configure just to use the paths to module name mapper. And the reason, let's just first quickly do it. Oops. We just need these three lines. We can just remove everything else here. And the thing is that in tsconfig.js, we have those paths aliases configured, and just by default will not understand that. So we have to configure just to work with that. Now, if we go back to package.json, you can see that Chimp added itself as a script. But similarly to what we've done with Jest, we have to tell tsnode that it needs to take the tsconfig paths into consideration. Sorry, tsconfig paths register. The other thing that we have to do, and this is specific to this particular project, is that we had a few GraphQL tools as dependencies. We will not be using them runtime anymore. They are moved to the dev dependencies, so we just have to remove them from the dependencies here. So GraphQL file loader and GraphQL tools load to be removed. Now we are ready to install the dependencies. Okay, so the next thing we'll do is we can hide the terminal now. We'll prepare the context. And what we want to have in the context is the data sources. So this is a typical pattern in Apollo. You create a function that returns an object with the initialized data sources. Then you'll add them to the Apollo server like so. But we do want to tell our resolvers that those data sources are there on the context. And the way to do this is here we'll say that the context will have data sources, and they will be of a return type of that function. And we can import the actual function. Okay, now we can start moving modules and changing them to be Chimp based. So we can remove the example module here, and we'll start with the library. So let's take a look at the schema and the resolvers. So the query, that's easy enough. We have a libraries query. But we also have two field level resolvers, library books and book library. And we need to tell Chimp to generate resolvers for these two fields and to connect them with the whole system. And we have two ways of doing it. One of them is based on the question whether a type has already a field of a given name. So what that means is the book library, as you can see here, already exists, but it is a string. And I know this because the comparison here compares the ID of a type string to the book library. So this is a string, but we want a library here. So in that case, we say link. And then in the case of library books, when we look at the implementation, we don't see that the library has a field books on it. And the way we load books for the library is that we just have an API that will fetch books for a library by the library ID. In this case, we just say computed. And this is important because, why don't we just have one API? We try to simplify things as much as possible everywhere. Why do we have two different ways of doing things? And the reason is that we want the types for the TypeScript types for those GraphQL types to be correct. If I just said computed here, then the library would not exist. And we want the library to be there, and we want it to be of a type string. Similar here. We want the books to be... We don't want the books to be there on the library type if it's not there. We don't want to give a user a chance to make a mistake here by adding a field that doesn't exist on the source. So the way the library comes from data source is it doesn't have books on it. Okay, so now with those changes, we can run yarn chimp. Now I just remember that we also need to update the data sources here. We moved the library module to modules. So we need to obviously update the path here. And that brings an interesting point that you could actually leave the modules where they were. We don't force you to have this structure. And the way to do this would be to just remove the -p source modules here. But realistically, when you are moving an existing application to Chimp, you will most probably have multiple modules there already. And it's not a good practice to do a huge sweeping changes at once. That would lead to a ton of conflicts and possibly lost code and bugs. So what we advise is to move those modules one by one. And this pattern helps you with that. So we will show you in a second that you'll be able to run the previous, the modules the way they were completely fine alongside with the modules that are already Chimp based. Okay, so a little side note here. So let's see, Chimp generated the queries and types for our library GraphQL. We have some errors here because we generate the schema in two places, and WebStorm doesn't like the fact, it seems to WebStorm that we duplicated some stuff. So the way to fix this is just we will mark the schema GraphQL as a plain text, and then we'll go here, and then this file as well will mark as plain text. They are loaded to runtime, and those are loaded only for code generation, so they don't collide with each other. But WebStorm is not very happy. Okay, cool. So now we want this to be green, like if possible. I know that we very frequently work with code where there are some errors showing, but that teaches us to just ignore those errors. So as much as it's possible, it's great to try to keep your code to just pass all the checks, ID checks, linting checks, testing checks, TypeScript checks, whatever you have. Okay. So another side note. Now we are ready to move the existing resolvers. We already have them opened to Chimp resolvers, and we'll start with the query. And it's usually very easy. You just, since both are Apollo-based resolvers, you can usually just copy and paste. Everything looks the same, with the difference that now this is all typed. So you couldn't, like here, you were able to just return anything you wanted. Obviously, there is a way to add types here, but the way to do it is that then whatever is in this object, we could check whether it's typed properly, but we wouldn't be able to check whether you implemented all the possible resolvers. So that's one of the reasons I think Chimp gets this better, because it forces you to implement everything that you have defined in the schema. And another advantage of having resolvers as isolated functions is that now we have the situation where this file can change for many different reasons, and that's typical anti-pattern in software development. Let's say one person adds a field to a library and another person adds a field to books, completely unrelated changes. Maybe we add address to a library and maybe we add reviews to books. So two unrelated changes, but two people making change in the same file, they get conflict, they have to resolve the conflict. Most people implement GraphQL like this, and you could have, hundreds of lines of code here and then multiple people making changes to this file at the very same time, working on completely unrelated features. So this helps because there's going to be only one reason to change this file. It will be to change the behavior of this particular resolver. So it's a much less frequent situation that you'll have conflicts here. Okay, so we move the libraries queries, and then the next thing we'll do is the library books. Library books, library resolvers. So again, we just copy and paste. Library, sorry. This is the one. So let's go in order then. So library books, sorry. Library books, let's copy, let's paste. Okay, and this one actually complains because it says that the author type is missing from the books. And this is caused because by the fact that here, Chimp already saw that we extend the book and we add an author field, but it's not coming from the data sources. So in this case, we want to say that this is a computed field, because again, the book itself doesn't have that field, right? So if we want to add a field that doesn't exist on the data sources, we use computed. And we rerun Chimp. And then let's take a look. Okay, this is passing now. Fantastic. We can remove this resolver. And let's go to the last one. And again, just copy, paste, everything works here. You can actually remove the resolvers file now. And now we would go to resolvers, and here we don't have this file anymore, obviously, and we want to use Chimp resolvers. An easy way to find them, to automatically import, is to just comment out this line, say resolvers, and then Webster will be able to find them. So we say resolvers as Chimp resolvers. And the reason for that trick is, and you can use this in other situations as well. If you want to import a named export, but you already have a name export, or you already have a variable defined in the same file, WebStorm will not allow you to just import it because there will be a conflict. So yeah, you can comment out the line, import it, and then rename it, and then this works here. The other thing we have to do is here we need to point at the generated schema, and that's because we add some directives like computed and link and a few other ones, and they are here in the schema GraphQL. And we want Apollo to know about them when we start the server. Let's see what's next. I think we can take a look at the test. So we had already an existing test. We have to just go one level higher to get the data sources and the schema. And let's run the test. The test is passing. So the test is passing, and it already checks that the Chimp and non-Chimp modules work together. But just to be safe, we can obviously start a new server. And I already have the query here. Let's try to run it. And we see this works. This query is actually straight from this test. And then the other tests are actually passing as well, even though they are not testing anything. And the thing here is that some of those resolvers are most probably not worth testing. And I'll explain in a second. So when you have one-liners like this and you have TypeScript, then there's usually very little reason to test this. TypeScript is already verifying that you are using things that are available for you and that you are returning the right types. There is no logic here. There's no if else. There's no looping. So there's very little reason to test this. In the library books, even though we are not doing any logic, there is tiny little bit that you might want to test, because you could possibly, that would be very silly, but maybe you were testing things manually and you put a string here instead of passing the argument, and TypeScript will not complain, linter will not complain, but the code will actually fail in a very weird way. So you might want to write a test for this. Again, that's something that should be easily caught in the code review. Like, people frequently in the code review might skip like bugs in some very complex logic and like maybe complex typings or something like that, but they'll probably see if you have some ID here hard-coded. But then we have this resolver that actually does some simple logic here. It finds things. So that's actually a good candidate for a test. So let's try to test that. Let's open this in the right. And let's see. So we want to say that on the context we have data sources and then library API, get libraries. And when someone calls this, we want to resolve with a library with matching ID and matching branch. And then we want to have another one, non-matching ID, non-matching branch. The parent, let's use WebStorm to implement all the members. And we are matching by the book library. So this has to be there. And we will just say that it's matching ID we call the resolver, and then we expect that the result of the resolver in this case will be this particular library. And we can run the code, run the test, and we see that it's passing. One thing to keep in mind though is that every time you first write the code and then you write the test, you want to make sure that the test is actually working. It's very easy to write a test, see it pass, and be happy about it, but then it might actually not be testing anything. Maybe you forgot to add an assertion, or maybe the assertion is done in a way that it's always passing. So the way to verify it is to break the logic that you are testing. Like that's my advice to you. And run the test, and you should see a failure. And you can verify that the failure makes sense, that it's not something completely different than what you would expect. And then, put the code in the previous state, run the test again to make sure that now it's passing. And now you have much higher confidence that this is done properly. All right, so now we want to move the author. So let's see, we move the folder to modules here. Again, data sources have to change. We have to say modules. And let's take the resolvers and okay, so we have only one book author, so we can run Chimp now. It will generate the resolver for us. So again, we can just copy and paste. But then we have an error, and the error says that the array of strings is not assignable to the array of bookdb objects. So taking a look at the schema, that's on the author DB object. So the author in the data source, we can see that the author books, it's an array of IDs, but we want the books here, right? So we know by now that we should be using link for something like this. So looks like that piece of code was actually missing in the original implementation, and just by the fact of moving this to Chimp, and this is a super simple example that we've made, and we even added a test, but just by the fact that we moved this to Chimp, we actually discovered a bug here, and believe me, this was not planned. Now we have another resolver here, the author books. And we want, on the context, we have data sources, and the library allows us to get books by IDs, and we want to pass the parent books there. And now, okay, now we can clean things up a little bit. So we don't need the resolvers because Chimp compiles all the resolvers together for us. And we don't need the schema because Chimp is taking care of that. So now the only thing we have to do is here we just import the schema from Chimp. We don't need the schema of resolvers. And we can start the application. Why is it complaining? Oh, not from combined schemas. Why is it importing it from there? No, because we mark this one as a text file. Oh, so it works both ways. Anyway, so let's import this one. We're just gonna say schema here and change this to the name, the export. Okay, and we can start. And I have a more complex query here. So the last thing that we implemented was this books on author, and we can see that this works. Yeah, and that's basically it. So as always, please let me know if you have any questions, and I hope this clears things up a little bit for you guys, and we all hope that you will enjoy using Chimp, and it will make your GraphQL journey more pleasurable. All right, thanks a lot.